Hello all, welcome to the another session. As part of our lecture series on nanomaterials or the nanotechnology, in this video I am going to discuss about the synthesis of nanomaterials. That is nothing but preparation of nanomaterials. In the previous sessions we have discussed about the importance of nanomaterials and why nanomaterials are showing special properties compared to the bulk materials. And we also discussed about which material we need to consider in the nano category and which material is out of the nano category, and different nanostructures, 0-dimensional, 1-dimensional, 2-dimensional, etc. And coming to the today's video or this particular topic, here we are going to discuss about the synthesis or the preparation of nanomaterials. The material might be anything. It might be ceramic, or it might be glass, or it might be any polymer, or it might be anything. But our aim is to prepare the material in the dimensions in between the 0 to 100 nanometer. That can be considered it as the nanomaterials. In this process, just imagine, initially the size is like a bigger particles. Our aim is clear. I want to get in between the 0 to 100 nanometer. So I need to cut down the size of the particles to the lower dimensions. Initially it is bigger. For example, initially it is like a bigger particles top, and we are getting into the down size, top to down approach. This kind of process is called as, initially it's like a bigger particles and we cut down into the smaller scales. That is called as top to down approaches. Here I want to explain the different strategies of preparation of nanomaterials. I don't want to go into the deeper in this particular video. That part I will discuss in each and every individual explanation. Here, initially bigger particles and it cut down into the smaller, that is called as top to down approach. Because we have different approaches, different methods, different strategies to prepare the nanomaterials. All these methods are classified under two categories. One is the bigger into the smaller, that is called as top to down approach. And the second strategy is, initially it is a lower dimensions and it is extract to the nanoscale, that is called as bottom to up approach. In general, top to down approach is like a physical method and bottom up approach method like a chemical method. Physical method means mechanical milling method or the grinding method or any other kind of method what we follow to cut down the particles into the smaller scales, that is called as top to down approach. But how we can explain, how you can understand which method is like a top to down approach, which method is like a bottom up approach? Just try to think the methodology what we are following in making the rice powder in the kitchen, or whatever the powders, grain powders in the kitchen. Initially rice grains are like a bigger size. Once it crushed into the smaller, like a powders will appear. So here what we are doing, rice grains are crushed for some time, then obviously it cut down into the smaller particles. Here one thing we can do, there is a possibility of getting like a different homogeneous particles. That's what we use like a sievage. We used to get the homogeneous powders only after sieving purpose. That is like a different strategies we need to follow in case of a top to down approach, but it is like it takes longer time. Obviously there is a inhomogeneous particles can able to appear, and there is a possibility of getting like a additional phases in the material. So this is the different strategies like to eliminate impurities. We are using different methods, and to get the homogeneous powders we'll use the another methods. So generally mechanical milling method or the ball milling method or the CVD method are under the category of the top to down approaches. But this top to down approach is very essential or the important method, especially for the industrial purpose, like when the bulk powders are required, because chemical process method won't give like 100 kgs or 200 kgs powders for batch. So then obviously we are using the mechanical milling method or the ball milling methods for this kind of purpose. That is nothing but top to down approach is useful for industrial point of view. And coming to the bottom up synthesis method, these are generally taken as the chemical synthesis method. Initially, whatever the material is extracted from the solution. Initially it is in the solution stage and it is extracted in the form of powders. This generally called it as bottom up approach method, because initially the powders are in the particles are in the lower dimensions, then we are extracting to the nano dimensions. These example for the bottom up approaches like sol gel, co-precipitation, hydrothermal, microhydrothermal, ultrasonification, solvothermal, laser ablation. There are different methods. Similarly, here also when we apply the kitchen methods here, making of jelly is like a sol gel method, making of cheese like a co-precipitation method, cooking in a pressure cooker is like a hydrothermal method. There are different strategies here we are improving the chemical activity between the different chemicals. Chemical reaction enhancement. Chemical reaction can be takes place in between the two different chemicals, and it can be depend on another parameter like a catalyst, external agent like a temperature, pH or anything. Here we are controlling these process parameters in the preparation of nanomaterials. In the process of controlling the different strategies of the different parameters, there is a possibility of change its structure. It might be a spherical shape, or it might be rectangle, or it might be any other shape, cubical, or it might be hexagonal, or whatever it is, or whether it is like a 0-dimensional, or it is like a rods like a 1-dimensional, or like a sheets like a 2-dimensional. So finally, whatever the methods we are following and what are the parameters we are controlling in the process of synthesis, that change the size as well as shape of the final powders. So chemical methods are most important, especially for the research point of view. And based on the methodology what we are following, then obviously the properties are completely different. But in case of chemical methods, there is a possibility to get the homogeneous and fine particles. And here the manpower is less, whereas in case of top to down approach, the manpower is more. Finally, in case of just simple assumptions in the kitchen, cutting down the particles or the grinding or layer by layer peeling, like just reducing the size layer by layer. So to understand the preparation strategies by observing the daily activities is essential to understand the like a nanoparticle synthesis. In the upcoming videos, every single method is explained in detail with diagrammatic representation, and what is the principle involved, what kind of chemical reactions are involving in that, what are the process parameter we need to monitor to control the size and shape of the particles. I hope you understand in what way we can prepare the nanomaterials. A small recap here. So nanomaterial synthesis can takes place in different ways. The total methods are classified into the two categories. One is bigger particles are crushed into the smaller, that is take it as the bottom up approach like mechanical milling, ball milling, etc. Whereas in case of chemical synthesis or bottom to up synthesis, initially the particles are lower dimensions and it extract to the nano size. So co-precipitation, sol gel, hydrothermal, microhydrothermal, sol gel auto combustion, all these are examples for the bottom up synthesis method. Thank you.